I gave you two options, let's say I'll give you a penny that doubles every single day for, let's say, a month, or I'll give you $1 million. Which of those options would you choose? For those who chose the $1 million, you would have $9.5 million less than the person who chose the penny. This is the power of compound interest, and that's what we're going to dive into today. Albert Einstein once said, compound interest is the eighth wonder of the world. He who understands it earns it. He who doesn't pays it. In today's video, we'll dive deep into the penny example. Then we'll dive into how compounding works and go through the actual math involved. Then we'll go into a couple scenarios of, if I wait to invest at this age versus this age, how much more or how will that affect me in my later years? So here's this very simple math using the penny example. On day one, you had a penny. On day two, you had 2, 3, 4, and on day 4, you had 8, and so on. But you can see by day 31, you have $10.7 million. If we look at this on a graph, you can see how in the early days, you can barely even see any type of change. But then it really starts to ramp up in the later days and periods. And this is where compounding really starts to shine. It's small and incremental in the beginning, but in the later years or periods is really when you start to see exponential or compound growth. So now let's go through another simple but a little bit more complex example. And so in this example, let's assume that you're investing $3,600 per year. This is only $300 per month, so this is very doable. And the return that you're getting is 10%. The S&P 500 has returned a little over 10% over the last 30 years. And so this is a reasonable estimation of the return that you could get. And so let's assume that you start investing at the age of 25. Your starting balance would be 0, but then you add in $3,600. You would get no return in that first year, and therefore your ending balance would be $3,600. That would then be your starting balance for the following year. You would add in another $3,600, but now you would get a return on the money that you already had in that account. And so in this example, you would get $360, which is equal to 10% of this starting balance. So then you would end the year with $7,500. It's pretty good. And so that would continue on, let's assume from age 25 all the way to age 67, you would end with $2.1 million. So what I want you to really pay attention to is this annual return column. You can see that in the early years, it's pretty little, $360, $750, $4,000. But then in later years, you really start to see this ramping up. And the last year, you earned $193,000 on the money that you had invested. If we chart this out, you can see the compound growth is very similar to what we saw in the penny example. And so it's small and incremental in the early years, but then it really starts to see that exponential growth and grow in the later years. This is, again, the power of compound interest. Okay, so now let's go through 3 other examples. And so using the exact same rate of return, 10% for all 3 examples, and then we're going to invest a different amount for various periods of time. And so let's go through option 1. So option 1 is I start investing at the age of 25. I'm investing $5,000. And so this is essentially $400 per month. And I do it from the age 25 all the way to 67. So you can see in this example, I'll have $2.9 million at the end by the time I retire at age 67. That's pretty darn good. All right, let's look at exact same scenario. So I'm still investing 400-ish per month, same exact return, but the only difference is I'm going to wait. I'm waiting till I'm 35 because retirement's so far away. I don't need to worry about that right now. I'm going to wait till 35. I'll start investing then. And so exact same thing, age 35, I start investing then. How much do I have at retirement? $1.1 million. And so the person who just started 10 years earlier, investing the exact same amount with the exact same return, has nearly 3 times more than the person who waited 10 years. This is a key reason why you should not wait to start investing. But let's look at just one more example. Let's say, what if I only invest between the age of 25 and 35 and then stop? I don't put anything else in. I'll still get the exact same return as the other two examples, but the only difference is I'll invest just a little bit more early, then let compound interest do its work. And so in this example, I'm investing $10,000 per year, or this is roughly $800 per month. But I'm only investing between the age of 25 and 35. So for roughly 10 years. And then at the age of 36, I'm going to stop investing. How much would I have in this scenario at the end? At the age 67, I would have $3.9 million. And so this is $1 million more than the person who invested continuously for the full 44 years. This is the power of compound interest. I can invest for 10 years and make sacrifices now, stop, and then let the power of compound interest really start to do its magic. So note that I'm not advocating for anyone to stop investing. However, I just wanted to show that example because it really highlights the power of compound interest and how if you put a lot of effort early and then kind of let it ride, you can let the power of compound interest do its thing. Are some of these takeaways kind of mind-blowing to you? Don't be discouraged by that. The human brain is really good at understanding the linear kind of repeatable growth, but we really struggle understanding compounding or exponential growth. Because of that, I'm going to go super deep into this topic in this video here. While I unpacked why does the human brain understand linear, but exponential is hard for us to grasp or understand. If there's any other videos that you want me to dive deep into, please leave a comment in this video and let me know what that is. I love personal finance and I love diving into all these topics. I'm happy to create any templates or anything that helps you in your own financial journey.